This video is about pedigrees. If you see a pedigree chart and you see a circle, the circles represent the females and the squares represent the males. A shaded in square or circle means that that individual has whatever trait it is that we are looking at. So sometimes we're looking at a trait that is dominant, and sometimes we're looking at a trait that is recessive, and sometimes we're looking at a trait that is sex-linked, and sometimes we are not. So all of the pedigree charts that we work with, if they're sex-linked, will be sex-linked recessive. We do not do pedigrees with sex-linked dominant traits, although those sorts of traits do exist. It's just that when you're beginners, it makes it a little bit easier if you keep it simple. So if you see a line between two individuals, they are mating pairs, and then each of these Roman numerals show a different generation. So Roman numeral individuals are the individuals that have the trait are the ones that are filled in. And if we want to understand the relationships between the individuals, if you look at these parents, they have 3 children, 2 girls and 1 boy. This individual is their son-in-law, and these would be their grandchildren. So they have a total of 6 grandchildren. Some things you might see in a pedigree chart could be twins. And sometimes you will see these little dots or a square or circle that's halfway filled in. If you see a dot or a square or a circle that's half filled in, they're letting you know that those individuals are carriers. They're being very kind to you. Sometimes we will give you a pedigree chart and we want you to tell us who the carriers are. So you will not always see this type of notation. So the Blue people of Kentucky are a very interesting way to look at pedigrees. There are some families that moved into the mountains, and the Fugits and the Richies both had an enzyme disorder that caused the skin to appear blue due to deoxygenation. There's actually a mistake in the enzyme NADH, which we learned about in cellular respiration unit. So here are some old family photographs. Now, Martin Fugit and Elizabeth Smith were both carriers of methemoglobinemia, and their son had it. They didn't know they were carriers until they had a son that had it. But if we fill in this pedigree chart, when you do pedigree charts, you always want to fill in the easiest ones first. You don't have to go in any particular order. You can jump around. But we know those individuals were homozygous recessive, and we know that those parents had to be carriers. And we can fill in the rest of these, but you're going to get a lot more practice with these. Notice that if you don't know for sure what the genotype is, you know it's dominant, big H, but you would put a dash. So we're going to be using that notation from now on. This is a pedigree of a sex-linked recessive trait. Now, one of the ways that you can tell if you're looking at a sex-linked recessive trait is that you'll see lots of males have it. Now, they have been kind enough in this pedigree chart to show you who the carriers of this trait are. And by the way, this is a trait for hemophilia, or this is a pedigree for hemophilia, showing in the European royal family. So Queen Victoria of England was a carrier, and you see she and Albert had lots of offspring, but then the royal families in Europe intermarried with each other. So all of these squares that are filled in have the trait. When you're doing sex-linked recessive pedigrees, and you would do this with any sex-linked pedigree, but we're not going to be doing sex-linked dominant ones, you fill out the males first. So all of the males that have no shading would be X big HY, and all the males that are shaded in would be X little hy, and then you figure out the genotypes of the females. Now in this case, they have told you who the heterozygous individuals are, who the carriers are. But even if they didn't tell you, you could figure it out, because half of her sons would have it. If any of her sons have it, if she has a child who's a hemophiliac, she is the one who passes it down. So any sons who have it, their mothers must be carriers. And any fathers who have it, their daughters would also have to be carriers, because the only allele that the fathers could pass down to the daughters is their X chromosome, which would have the mutation on it. So when you're trying to figure out the genotype of females, it's important to look at their sons and their fathers for that clue. So sometimes we're going to be telling you how the trait is inherited, and other times we're going to be asking you to tell us. So if you have a set of parents and they both have a trait, and one or more of their offspring don't, the trait has to be dominant. So in this case, both parents are, I just picked a letter out of the hat, but big H, little h, and they can both pass down the recessive allele. If you have two parents that don't have the trait and a child that does, it has to be recessive. In other words, you want to look for generation skipping. If a trait skips a generation, it has to be recessive. Now, in this case, your next question is if it's recessive, is it Sexcellent recessive or autosomal recessive? If you have a daughter that has it and a father that doesn't, it can't be Sexcellent. It must be autosomal recessive. Now, in this particular case, we know that the trait must be recessive because it skipped a generation. We have two parents that don't have it and a kid who does. And in this case, we don't know. It could be autosomal recessive or it could be Sexcellent recessive because the male could get it from his mother who could be a carrier. So we can't tell. The only way to know for sure is to have more information than this. So if we have a really big pedigree chart, like this one, and you have a lot of males that have it and no females that have it, that's a really good indication that it's Sexcellent recessive.